Phase Change Engineering Internship Day 4, Analyzing Incubator Materials. If you're watching the video instructions, they cover the entire lesson, so you will need to pause the video when necessary. Activity 1, Connecting to Futura Workspace. You'll read and pin today's message, Materials Analysis. Then, you'll add to your daily message notes by creating a new header with today's date and message topic. Students open Futura Workspace and read the daily message from the project director. Remember that the new message titled Day 4 Materials Analysis should be at the top of the inbox and that you should pin the message. Add notes to the top of your existing daily message with the new heading Daily 4 Materials Analysis. All of the notes you take for this message should fall under this heading. Ensure that you are clear on your tasks for the day. Completing the PCM analysis, completing the Incubator Materials Analysis, making annotations for Chapter 4 of the dossier, after hours work completing the project summary. Teacher, using models. Anton Green, your project director, has sent you a new video message. The video provides information about why engineers use models. Students, play the video. Why might engineers need to use models in their work? We might say to learn more about processes that would be difficult to test in real life because they are too complicated, too far away, too small, or too large to see with the eye. The processes are too dangerous or risky to test on humans, or the processes take too long to test in real time. Remember, a model is an object, diagram, or computer program that helps us understand something by making it simpler or easier to see. Some types of models are three-dimensional physical models, diagrams, or computer-generated simulations, like baby warmer. All these models represent something complex that is made easier to study by using a model. Why is it important for us to test our baby incubators with a model like baby warmer? We might say, we don't have access to real babies and wouldn't want to put real babies in danger. What limitations does our model have? We could say, not all babies react in the same way. We can only test certain materials. We don't get data about how well the baby is growing, only about temperatures. Baby warmer displays results in numbers as well as graphs. We'll need to look at both to understand how well your designs performed for each test. The number values and the results are rounded to make the data easier to interpret. Teacher, analyzing incubator materials. Futura engineers chose specific materials to use in the incubators. Your job now is to determine the best combination of PCMs and insulating materials. Remember that the engineers chose these materials because of some constraints or limitations of the design solution. These constraints included things like requirements for the heating materials being reusable, capable of being heated without electricity, and ease to use. These constraints helped Futura design the basic sleeping bag and phase change materials for the incubator. Remember that Anton will use these criteria to decide how successful your designs are. Keep the baby's average temperature as close to 37 Celsius or 98.6 Fahrenheit as possible. Minimize the time outside of the healthy temperature range, and keep costs low. The materials are variables, things you can change. Today, you'll test one material at a time to see how each one affects the criteria. This is called isolating variables. Isolate, to separate or set apart. At Futura, we isolate variables so we can understand which ones lead to certain results. Today, you will isolate and test materials in the design tool as part of your research to better understand how each material affects the results. As you run your tests in baby warmer, you'll use these sheets to record the data you gather. You'll start with the PCM analysis. The PCM analysis sheets list important details for each PCM: plateau temperature, plateau time, reheat time, and cost. Students, notice these sections of the PCM analysis sheet as you review the details. Plateau temperature defines the specific temperature of the phase change. Plateau time refers to how long the temperature plateau lasts during freezing. These are not listed as exact times because it depends on the incubator conditions, which can affect the rate of thermal energy transfer. Reheat time refers to the time it takes to change the PCM from 35 Celsius, when it is removed from the incubator pocket, to 39 Celsius. The reheat time returns the PCM to the liquid phase before it can be used in the incubator again. The time of this phase change is specified in minutes because the temperature of the boiling water is constant. And so we know how long the energy transfer from the boiling water to the PCM will take. Cost is per PCM packet. Remember that the incubator cost starts at $20 and then increases for each PCM packet or insulating material included in the design. Let's run a test on PCM-A together as a class. You'll fill in the PCM-A section on your PCM analysis sheets as we go. We want to see the effects of one PCM type when no other variables are changed, so we'll put PCM-A in every pocket. We won't include any insulating materials. In this set of tests, we are isolating for PCM type. We want to see the effects of one PCM type when no other variables are changed. Let's look at the results, which are related to the project criteria. Record the results on your sheets. Students, record these results on your PCM analysis sheets in the table Isolating PCM-A. To focus on just the PCM cooling graph, we'll hide the lines for the baby in healthy range. Now we can analyze the plateaus on the graph. Keep in mind the details that we can interpret in these phase change graphs, such as what temperature the plateau occurs, how long the plateau lasts, and how long the PCM needs for reheating. Be sure to notice on the reheating of phase change materials graph that it shows the duration of time the PCMs are outside the incubator and in boiling water. We can annotate the graph to show where each detail comes from. Annotate the PCM-A graph on your sheets as I point out the parts of the graph. Notice each part of the graph and the related detail listed on the sheet: plateau temperature, plateau time, and reheat time. The total cost is calculated by adding the cost of 4 packets plus the base cost of $20. This design uses 4 packets of PCM-A, which costs $15 each. The incubator without any PCMs or insulating materials costs $20. After you have the test results for all 3 PCMs, you will use the pros and cons section of the sheet to compare their strengths and weaknesses. Pros are things that are a strength and make your design better, and cons are things that are weak or make your design worse. For our PCM-A test, the baby's average temperature was 35.8 Celsius, which is below the goal of 37 Celsius, so that is a con or weakness of PCM-A. In addition, the time outside the healthy range was 720 minutes, the entire test time, which is a significant con. You can return to Futura Baby Warmer and turn on the healthy range and baby's temperature in the Futura over time graph to help interpret this result. Run isolated tests on PCM-B and PCM-C and record your results. Once you've finished, discuss the pros and cons of all 3 PCMs. Complete the remaining isolated PCM tests. For the 2 remaining tests, if you have a partner, you can complete one of them and then share the results, or, if time permits, each one of you can complete both tests independently. Let's discuss a few pros and cons of each PCM. PCM-B. Pros: high plateau temperature, short reheat time, low cost. Cons: short plateau, baby outside range too long, plateau temperature is above healthy range. PCM-C. Pros: medium reheat time, baby short time outside healthy range. Cons: high cost, medium plateau temperature. Pros should be properties of PCMs that help keep the baby's temperature within the healthy temperature range, like longer plateaus, plateau temperatures that are within that range, and a shorter reheat time, and keep the costs low. Cons are properties that put babies in unsafe temperatures, like short plateaus, plateau temperatures that are too high or too low, or make the incubator costs too high. Make sure to keep this analysis on hand because it will help you make design decisions as you work to make your incubator designs. Next, you will test insulating materials. You'll continue isolating variables to understand how each material or number of layers impacts the incubator system. Have you ever heard of insulating materials or insulation? What do you know about insulating materials? We could say building insulation, coolers, or mugs to keep things cold, warm, as well as clothing. To figure out how insulating materials are important to portable incubator designs, you'll continue doing isolated tests. Later, you will read the dossier for additional information about how these insulating materials affect the incubator's performance. You'll use the Insulating Materials analysis sheet to record the results of your tests. Let's review the data you record and the 2 questions you'll answer. You will need to split up the testing. One partner should isolate the variable of material type, and the other should isolate the number of layers. You will share your results with each other and then discuss the questions on your sheets. Remember, when conducting isolated tests, everything should be set up the same, except for what is being tested. If you are isolating the variable of material type, you will change the type of insulation material each time, but use the same number of layers in every test. If you're isolating the variable of number of layers, the insulating material remains the same across the test, while the number of layers is the only thing that changes. For practice, let's analyze these test results, which are for a design using no insulating materials and no PCMs either. The time slider at the bottom of the screen lets us see exactly how many minutes it took for the baby's temperature to drop to 35 Celsius. When you run your test, there might be some variability in the number of minutes due to rounding, but you can record the last minute that reads 35 Celsius. Here's how we would fill out the data for this test with no insulating materials. Run your isolating materials test and record your results. Then share what you observed and discuss the questions. Students, conduct your insulating materials isolated tests. Be sure to understand that you will not test all possible cases, but instead you will record all possible case data as a group. Next, you will share the results of your tests with the class. I'll project a large version of this data table for us to fill out and discuss. How do different insulating materials affect the baby's average temperature? Well, wool takes the longest for the baby's temperature to drop, so the average temperature is higher. Fleece is better than cotton. Wool is the best because it slows down the rate of thermal energy transfer from the baby to the surroundings. How does the number of layers affect the baby's average temperature? When no PCMs are used, more layers of insulation increases the number of minutes it takes for the baby's temperature to drop. More insulation slows down the rate of thermal energy transfer from the baby to the surroundings. More layers of wool is more effective than more layers of cotton. What else do you observe? Possibilities would include wool is very expensive. 2 layers of cotton have the same effect as 1 layer of fleece. More layers of cotton do not increase the number of minutes, so it might not be worth using it. You just did an in-depth investigation of how changes in an incubator structure, what PCMs and insulating materials are used, affect the incubator's function, or how well it keeps the baby warm. You use this information to begin creating your optimal incubator designs in the coming workdays. Keep thinking about the observations you made as you read about insulating materials and get ready to start your incubator designs. Activity 2, reading about insulating materials. You'll continue your background research by reading Chapter 4 in the dossier. This chapter will help you learn more about insulating materials. Remember, you've researched PCMs, temperature plateaus, how PCMs work in the incubator, and the pros and cons of each specific PCM available for the designs, as well as tested insulating materials in the design tool. You'll read the chapter the way an engineer would, making annotations of questions and connections related to this focus question. You can open the dossier using the link in the daily message. Read and annotate Chapter 4, Insulating Materials, in the dossier. Share your annotations, including those that helped you answer the focus question. Insulating materials, substances that do not transfer thermal energy very easily. How can insulating materials affect how PCMs transfer thermal energy in the incubator? We might say insulators can slow down the transfer of thermal energy. Since insulating materials are on the outer part of the incubator, on top of the PCMs, they keep the PCMs warmer longer. When there are no PCMs in the incubator, insulation keeps the baby warmer longer. Earlier, we discussed that wool was the best insulating material. Will it always be the best? And why? We might say, maybe not. If the PCM plateau temperature is too high, that means using a good insulating material will keep it warm for longer, but the baby will be too hot. Students, be sure to answer the self-assessment question on the activity and then select Hand In. Activity 3, After Hours Work. For this task, you'll complete the project summary form. It will give you the chance to record some of your early ideas about incubator designs. You've worked with the incubator materials today and have learned more about how the materials affect the results, which are tied to the project criteria. The project summary form will be submitted to Anton so he can see what you understand about the project. For the next task, you will talk to a member of your household and explain why portable baby incubators use PCMs. To do this, you will need to complete the Explaining Portable Baby Incubators at Home form. Students, complete the after-hours task. End of lesson.